Hello, everyone. Good morning, good evening, good afternoon, and welcome to the Data Services Office Hour. I'm Michelle DiPalma, your host, and I'm here with the amazing Annette Clewett. Hello, Annette. How are you?
Hi, Michelle. I'm good. Yeah, it's bright and early here in California, but I'm ready to roll.
It is a little early.
Yeah.
So, talk to me about what we're going to go through today and what our topic is.
Yeah, what we're going to do is we're going to continue, because this is not the first session that you've done with me, but we're going to continue to talk about the evolution of disaster recovery for Openshift. And we're getting better at it, and we're doing more automated features to make it easier. So we're lucky that just yesterday the latest version released for Openshift Data Foundation, which includes all the new disaster recovery operators. So
is that 4.11?
Yeah.
Okay.
To go with Openshift 4.11 that recently released. So we're going to be looking at the newest capabilities, and hopefully people will find it exciting.
Fantastic.
All right. Well, let me go ahead, and I'm going to just start with some slideware.
Okay.
And then we'll go from there. Let me know when you can see it full screen.
Full screen. Perfect.
Okay. So we're going to discuss, just sort of basic why do we need disaster recovery for containers, what the components are in terms of an Openshift solution, what assets we have, and then some context. So to start with, we have, the problem statement for disaster recovery is not any different than when we had legacy applications. It's really the same issue. It's just now it's container-based or Kubernetes-based platforms. So the challenge is, how do we map to the legacy disaster recovery approaches? How do we trust that this new disaster recovery capability is going to work? And if we have regulatory requirements, that it's going to meet those requirements. And also, this is a relatively new solution for both Openshift and the operators that have been developed. And it is a combination solution. So we have dependencies with different operators like Advanced Cluster Management, Openshift Data Foundation, and then outside of Openshift, Red Hat Self-Storage. So all those things sort of have to come together at the right time to produce the solution. By doing this, if we are successful in doing disaster recovery for containers on an Openshift platform, then we will have a way of actually failing over to a new cluster environment and being able to provide service. As we'll see, there's some measurements of how well we do that. And we can make sure that in the case of a problem, that we do have an alternative. And it creates a methodology. If we have regulatory requirements, we can provide the methodology for that so that we meet that requirement. So the goals for disaster recovery, or the way that we measure it in terms of, are we actually meeting requirements, is we try to set the requirements up before we even have a disaster recovery plan. So recovery point objective is a measure of how much data can you lose. And recovery time objective is how long can the application or service be unavailable. So it is possible to have your recovery point objective be essentially 0, meaning you don't lose any data, but you most likely will still have application downtime. So at least in terms of the way that we're approaching it for Openshift. And again, these are not new terms. They've been around for a long time. We're just now applying them to Openshift and Kubernetes. So the solution overview, we have created sort of two flavors, and they're similar in how you configure them, but they have some differences. So we've called one regional disaster recovery and the other metro disaster recovery. So regional disaster recovery will be a solution where we pair OpenShift clusters, and the distance between those can be quite large, meaning we don't really have a latency limitation between the clusters. We're going to use a replication strategy based on interval replication. Say we replicate every 2 or 3 minutes. We'll set that, and then the data will be essentially sent to the opposite cluster, the peer cluster or the failover cluster on that interval. And in that case, our recovery point objective, we could have as much outstanding data as our replication interval. So if we haven't replicated the data and we have a failure, we would lose the data that had not been replicated.
Okay.
MetroDR is a solution where we use a storage plane provided by Red Hat Ceph Storage that is outside of OpenShift. We still have the idea of a failover cluster, so we create sets of 2 OpenShift clusters, connect them to this external storage plane, and then when there's a failure, we can fail over. Big difference is this solution can provide recovery point objective of 0 because it's a synchronous solution. So there's no outstanding data that has not been replicated. It does require some additional steps to do the failover. So you would still have a recovery time objective, which you would need to meet, meaning how long is the application out?
So quick question on MetroDR, you mentioned, so Ceph is external in that case. So there's also
and I'll
management.
show a
Okay.
diagram in a bit here.
Okay.
So, but
Okay,
did you have any other question?
No, we'll look at the diagram and just make sure the points are
Yeah. If it's not clear by then, certainly let me know.
Okay.
So what components within Red Hat products do we use to do this? It's required that we have Red Hat Advanced Cluster Management. This is really allowing us to use the automation available in this operator and custom resources. And then it's also all of the disaster recovery that we're developing, the automation, the custom resources are coming in through Openshift Data Foundation. Like I said, we just released yesterday available Openshift Data Foundation 4.11. And then used by Openshift Data Foundation, as well as a standalone offering, is Red Hat Ceph Storage. So Ceph Storage is used in Openshift Data Foundation, whether it's on OpenShift itself or whether it's external to OpenShift. So those are the 3. And then within the disaster recovery capability that you get with OpenShift Data Foundation, we're going to have 3 additional operators: the DR Hub operator, the DR Cluster operator, and the OpenShift Data Foundation multi-cluster orchestrator. And it says regional DR only. Should have fixed that. That was for 4.10. OpenShift Data Foundation multi-cluster orchestrator is going to be used now for both metro and regional disaster recovery, and does a lot of the automation and setup. So that operator is used in DR for all solutions. And then go back real quick. So it's still, this still requires that you use Ceph volumes. So, you're going to be using your storage classes that are provided with ODF. One restriction or today with the regional DR is that for support, we only support block volumes or what we call the Ceph RBD volumes. That'll be changing. And we already have a tech preview solution for RWX or Ceph FS volumes. But by 4.12, all Ceph modes, RWX, RWO, will be supported. For Metro DR, there is no, it supports all volume modes. Just showing here quickly sort of the expectations for RTO and RPO that we talked about earlier, recovery time objective, recovery point objective. The Metro disaster recovery is a good solution if you have to not lose data, but it does have a distance limitation, because just like any synchronous communication, it will have a distance limitation if you want your write latency to be usable. So right now we're saying no more than the two Openshift sites that would be paired together for Metro DR need to be not more than 10 milliseconds round trip time apart from each other.
Okay. That's
so
close.
Yeah, well, 10 milliseconds in my experience of how the bit might travel could be up as certainly above 500 in the US, 500 miles apart. So it's it's a limitation, but it's not like they have to be across the street from each other.
Right.
So just looking a little more into the regional disaster recovery, again, there is no distance limitation for this solution. The two sites can be as far as your environment requires, and it does again use ACM in terms of the automation. That GTM at the top there is global traffic management, might be global load balancing, might just be load balancing, but it does require an external load balancer for being able to, if you have connections coming inbound to one cluster and that cluster goes away, then you need your load balancing to switch over. So that's what that is.
So the load balancing is external.
Yeah, I mean, most enterprises within their IT infrastructure offer load balancing to applications. So you shouldn't have to create one yourself if you're trying to test the solution. But you could use something as simple as HA proxy and put it on like a virtual machine or a server or something, and just set it up. It's relatively simple if you needed it for testing. So one point here is that though it shows the left-hand side is the active and the other one is the passive, that's really on a per application level. So you could certainly have some of the applications on cluster 2 in an active state and their failover cluster be cluster 1. So it's not required with this solution that all applications are active on the same cluster. They can be active on the other cluster and then have their failover cluster just be the opposite. This makes use then, if you want to have resources used on both clusters and not just have a cluster sitting there doing nothing, you could sort of have some applications active 1 and then some on 2, and you would be using your resources more efficiently. The only thing you have to make sure is if there's a failover, that you have enough headroom on either cluster to run all applications. Did you have a question, Michelle?
No, I think I was just going to say that's great, and I'm sure we won't. I don't know if we'll have time to cover this here, but if you didn't want to run, let's say you split up your applications nicely, and then something happens, you go to fail over and you don't quite have enough resources. Can you scale? Like, I was just wondering about, like, do you always have to have those resources sitting around, or are you able to scale up recently? But that we can talk about that later. Like,
Yeah, I
later.
would think I that's, I don't know that much about the area of OpenShift and scaling up resources, but if you're using IPI and machine sets, right? I certainly think that would be very possible to scale on demand, but I don't know if that would be, sort of a separate step. You would scale essentially your nodes and your resources so you had more places to schedule, or could you do it from the application point of view and have it actually scale and then say, hey, I need more nodes or more resource. But with machine sets, that would definitely be possible to scale when needed, right?
Right. Yeah. Cool. Okay.
Um, yeah, and I'm sure there's some amount of automation around that too. So MetroDR, get a view of that. Again, still have the 2 pure clusters. We're only showing 2. You can have many sets of clusters, really as many as you want. So it's just, the idea is that each cluster will have a failover cluster, but I could have, I could be having disaster recovery for, say, 10 OpenShift clusters, and they would just be configured into pairs. So that I had 5 failover clusters.
And
So in
that's
this
at the
case,
application level? Like, if you had, let's say you did have 10 and you split them up into 5 and 5, and you decide could you just go in at the application level and decide where this application, what cluster it's going to fail to?
yeah, essentially you do that, but in terms of what we call the disaster recovery policy, you set up the policy ahead of time so that only so when you go to apply the policy to the applications and tell it what failover cluster it has, you already have that configured. So you can't just say, this application will fail over to any one of these 5.
Okay.
It'll be one. When you create the DR policy, you're going to say, this is your failover cluster. Any applications are going to use this peer relationship.
Okay, gotcha.
So,
Okay.
yeah. So again, we have external ODF. We call that Red Hat self-storage. It uses the external mode capability when you install Openshift Data Foundation to connect to that external cluster. The cluster has to be configured, the Ceph cluster has to be configured in an architecture called stretch mode with Arbiter. So that's a particular configuration, so that we essentially can ensure that if everything in the site data center 1 was unavailable, that the data would still be synchronously replicated, and there would be enough replicas of the data on everything in data center 2 so that your applications could still run. Now, the Arbiter node must stay available if there is a failure. So it has to be somewhere which is not data center 1 or data center 2.
Okay.
It can run it's just what we call a monitor service. So it could run in a cloud environment on a say EC2 instance or something, as long as there's reachability back to the Ceph cluster.
Quick question. Are there latency restrictions on the Arbiter node as well?
Good question. There is not latency restrictions for the most part. We're talking about maybe a restriction of 100 or 150 milliseconds. So for most realistic, locations, that's not really a restriction. I mean, that would cover any place you wanted to put it in the US.
Right.
Or even if you had, for some reason, you had your data centers in the US and you wanted to put your Arbiter somewhere in, I don't know, London or something, or even farther somewhere in Asia, you would still be good.
Okay.
So again, distance limitation for the two data centers that are hosting the OpenShift clusters, as well as the main components, the data nodes for the Red Hat self-storage. So we're going to look at one of these assets, but right now, I think, Michelle, you're going to bundle up this PowerPoint or turn it into something that we can make available to people.
Sure.
Hopefully these links will still work, but these are some assets. We just, with a new version, we just released the latest disaster recovery, and it has combined now the regional and the Metro DR instructions into one guide. And I think if I switch, let me know if you can see this, Michelle. Can you see this or no?
No. You want to switch to a video?
No, I just want to switch to a different window, I think.
No. Oh, wait, hang on. Now I see us.
Yeah.
And if you
No,
share
I'm just going to
again.
try real quick to switch to a different
Okay.
window. Okay. Can you see this now?
Hey, yes.
Okay. So this is our latest guide that was just released yesterday, and I just want to make it clear that it's got the regional disaster here, and there's a whole set of instructions that go with how to configure that, including what you need to do on ACM. And then, let's see here, how do I get this to go down a little bit more? And then the same guide will include the Metro DR solutions. So you know, detailed instructions here on how you're going to set it up. It's just that these were two different guides, and now we've collapsed it into one guide.
Okay.
All right. Well, I think we have time and should get on to a demo, right?
Awesome. Yes.
Okay. So let me stop sharing here. And are you going to start the video or should?
Do you want me to?
Like, there we go.
Perfect. Okay. And I'm going to maximize it. Okay. There you go.
All right. Let me see if I can control it here. All right. So I'm going to show you a demo. It is pre-recorded, but you will be able to watch it afterwards. So again, I'm Annette Clewett. I'm a principal architect in an engineering disaster recovery team. So what we have here in Advanced Cluster Management is we have, in addition to the local cluster that has advanced ACM installed, we have 4 other clusters that I imported. And again, this goes to, we'll see later that these have 2 different ways of either synchronously or asynchronously replicating the data. And then what we want to look at is what is installed on what we call the hub cluster. So we have a hub cluster. On that is the Advanced Cluster Management, the ODF Multi-Cluster Orchestrator, and the OpenShift Disaster Recovery Hub. So these operators and their custom resources are coming when you get the advanced subscription for OpenShift Data Foundation in terms of support. On each one of the what we call managed clusters, I'll just show you one here. We also have some operators that we must have, which is OpenShift Data Foundation is installed, and OpenShift DR cluster operator. So let's go ahead now, and in order to test disaster recovery, we're going to create an application. And the application that I'm going to use is going to be at a GitHub repo that I forked from some application samples. And what the reason that I forked it, we'll see, is so that I could configure the storage class to use an OpenShift Data Foundation Ceph RBD storage class. So it has a persistent volume, and I made that be configured and used by Ceph. So now we're going to place our application, and this is all ACM on one of the clusters, and this one will be one of the ones called BOS, and this will be BOS1. So we're going to go ahead and create, and again, nothing about disaster recovery has been done yet. We're just basically using ACM to schedule an application on a particular cluster that it manages. And
okay, so just to drive that point home, this is scheduled from ACM, not in one particular cluster. So, right, if I had an application running,
yeah, no, this is good. Yeah, let me clarify. I just stopped the video for a minute.
okay,
This is absolutely scheduled on one of the managed clusters, not on the hub cluster.
right,
Because
okay.
all ACM is doing when I configured that a little while ago is I'm just told it where do I want Pacman. I could have picked any of the 4 managed clusters, but I picked this one.
Okay.
So the applications that you schedule via ACM don't run on the cluster that has ACM usually. I mean, it could if it was just a small test, but for disaster recovery, it needs to run on one of the managed clusters.
Okay.
Where Openshift Data Foundation is actually installed.
Right. Okay.
So we've got that now. Pacman is running on one of the clusters, and what I want to do now is I want to actually go play the game. And I want to play the game so that I can create some persistent data that will be written to the Openshift Data Foundation Ceph RBD volume so that we can actually test the failover. And I'm doing very badly here. And the reason is because after I fail 3 times, I get to save a score, and that will show up again in high score. So this data is persisted to the volume, and in this case, this is the data that we want to preserve if we have a failover. So to set up so far we haven't set up any disaster recovery, but we need to do that, and the way we do that is a new capability called data policies. And we're using the multi-cluster console. So I'm going to create a new DR policy. And the DR policy is not immediately assigned to the applications. That'll be another step, but we're just going to basically say which 2 clusters are paired together, meaning that we want them to be able to fail over and protect the application.
Okay.
And when we select them, it'll come back and tell us what their relationship is. So it is able to actually inspect those 2 storage clusters, and we can see that it's asynchronous. By default, the synchronous interval is 5 minutes, but we can change that to be either shorter or longer. The minimum replication interval is 1 minute. So I create this now, and then I want to also create one just to show for the other 2 clusters, just to show how they are different. So in this case, I'm not going to put into my name a replication interval, and I'll show you why in a minute here. I'm going to not need that because when the inspection was done of these, you notice it says OCS external storage cluster storage system. So this is actually connecting to Red Hat Ceph storage. And
sorry, so it was able to detect that these are both connected to external Ceph. So
yes.
Basically, this is a Metro DR situation.
Absolutely, yeah. The other one was
regional.
The other policy that we created was essentially mapping to regional DR, what we call regional DR, and this one is mapping to Metro DR. Yeah, 100%. But the main thing is, well, it's not the main thing, but one of the things is that you don't have to know. You just have to select the right clusters. Like if I had selected, say, perf1 and bos2, that wouldn't have worked because they're not, they don't, one is set up for synchronous, the other is set up for asynchronous, and that's not going to work.
Gotcha. Okay.
Okay, so I'll go ahead and continue the video. So we've now created or we're going to just in a minute here create the second DR policy or data policy, and now we can use that to assign it to a application. So I'm going to choose to use the first one I did, which is, as Michelle said, is a regional DR, and I'm going to apply the policy to my Pacman application. So at this very point now, there will be some new resources created in the Pacman namespace, and one of the most important ones is called DR control placement, and we'll see in a minute what that.
Okay, so at this point, we should be looking at the Pacman application that is set up over regional DR is ready for failover, right? Like if we pull the plug on one side, we should see it fail over to the other.
Yeah, so what we're going to do is we're going to now go ahead and try the failover. And to do that, we're going to use that DR placement control that we just created.
Okay, so you're still on the hub cluster right now, right? You never really go down into BOS1 or wherever we placed.
Yeah, correct. It is the hub cluster. The custom resource for this is on the hub cluster. Let me just explain that real quick.
Okay.
Sorry.
No worries.
I had time to have a coughing fit. So when you think about it, if let's say a managed cluster that has active applications that are protected by this DR placement control becomes totally offline, then you can't communicate with it, right?
Right.
So that's why the hub cluster is really critical, because we're doing this from the hub cluster. Even if we had no communication whatsoever with the cluster for the applications that we want to fail over, we can do that at the hub cluster because the data has already been replicated to the opposite cluster, and we're recreating the application from a GitHub. I mean, the GitHub has to be available.
Okay.
But all the resources that are going to recreate the application are not on the cluster that's offline right now.
Right, right.
So this once we set the action to fail over here and the failover cluster and save it, all that's going to be initiated. You know, rehydrating the application from the GitHub, mounting the replicated storage, and we should be able to see if our application works and that our data persisted.
Okay, so in this demonstration in the video, you're forcing the failover to happen, right? You're not going to bring down BOS1.
No, I am in this case, this is just, a test, which actually is a good point because a developer will have namespace control, and a developer or someone who owns the application could actually do this and test failover, and they would not impact anybody else. It would be only for their application.
Okay, nice.
So yeah, it's a per application failover, and it can be initiated at any time.
Okay.
I mean, as soon as you apply the DR policy to the application, then you're able to test it from then on.
Okay.
Okay, so we're going to add action. And the action we're going to add is failover. And right after that, we only have to do this once, but we're going to add the failover cluster that is in the DR policy that we chose.
Right. Okay.
Which is going to be BOS 2. And then we'll go ahead and save that. And let me just make one point because I can hear the question coming, which is, do I have to do this initiation via a YAML file anytime I want to fail over? And the answer today is yes. You do have to go into this YAML file and put in the values I just put in.
Okay.
But in the next version of the product, 4.12, you will be doing it via UX, via the UI.
Okay.
And you won't have to be modifying YAML files or anything like that.
Okay.
So we're going to save that, which I think we did. We can look at the failover now in a couple different ways. We have event stream, and if you read that, you'll see it's doing it. We can also go back here, and if you look closely, you'll see we're on BOS 1, and we just switched over to BOS 2.
Okay.
So we've now done that, and the question really is just if, does Pacman work?
And I was going to say, is your low high score available? That's the question.
Exactly. And then let me just pause for a minute here.
Okay.
So this is the load balancer that I talked about earlier. We can see that in the middle of the screen there, that one of them is green, one of them is red. So that's the job of a basic load balancer, right? Is point connections to the instance that is currently active. And that right when we did that switchover that we saw on the topology, they were both red before because both of them were down. Remember, when we fail over, we take down the application on the opposite cluster. So the application only runs on one cluster at a time. But as soon as the Pacman application came online on BOS 2, the failover cluster, this went green, and any incoming connections, which I'm going to do in a minute here, then would go to the failover or the second cluster.
Question. So when the application failed over to BOS 2, all of the steps are taken? It pulls from the Git repo? Is it?
Yep.
It's okay.
Yeah, and it mounts the latest, mounts the Ceph volume image with the latest replicated data. Okay. So again, if we had done the high score and there hadn't been time for it to, let's say there was a failover 1 minute and it hadn't done the replication, then we would mount it, we would not see it. Okay. Because it didn't get replicated in time. Okay. So your replication.
I was just wanted to be clear for people. So it's true disaster recovery, not HA, right? The second
absolutely, yeah. That's a good. Yeah, it's not just providing a possibility of recovery. It's actually it's saying the alternate site is no longer used at all.
Okay, gotcha. Okay.
Okay. So we're continue here. I just wanted to make it clear about the load balancing. So we'll go back to our application. We need to refresh because we're on a different cluster now. And then we can go to the high score. And there it is. So it had time to replicate. And, this is just a simple example. But, the idea, even if you had applications that had high I/O, you should be able to get all of the data available in the alternate cluster, and the only outstanding data for regional DR would be data that had not been replicated. So choosing your replication interval is really important, because, that's going to essentially create or determine your replication interval.
Okay, so the first decision you would have if some a customer came to you and they were going through their use cases, it's definitely RPO, right?
Right.
That's the first
You
question
can
that they have to
probably
answer, right? If you're a
you can
hospital,
probably take down the
right?
the
Oh
video. No,
yeah,
I don't know
hang
how
on,
you.
sorry. We're all staring at a video instead of staring. Okay,
It's okay.
so RPO, then RTO, with RPO being the driving factor.
Yeah. Yeah.
Okay, and then,
So yeah. And if that had been asynchronous, if it had been the other two clusters, then we wouldn't have lost any data. I
right,
mean, because it would have synchronously replicated. We would still have application downtime because it takes time to rehydrate the application and to mount the storage. So we would still have time when the application would be unavailable. So incoming connections, basically that load balancer would show red, like I have nowhere to put the connections. There's nothing active.
okay, and so if you wanted to minimize that time, let's say things are really sensitive, so we're
Right.
definitely doing Metro DR, and you wanted to say not be dependent on GitHub, you just make sure you have a repository, that the cluster can reach, like, start to
Right.
remove external dependencies and bring it all
Yeah,
to
yeah,
single.
and the other thing there was application set ROCD. So there's all the ways that ACM supports essentially creating applications. We can support that. So as ACM evolves to be able to have more ways of creating applications, then we just basically piggyback on that.
Okay, I see.
Yeah,
And for,
yeah,
we talked briefly about the arbiter node for external Ceph.
right.
I mean, it make I so the requirements for the arbiter node and for ACM or the ACM hub are the same. I'm not using the right words for ACM, like
Well,
meaning that
in a way they are. They both need to survive.
right.
And
Okay.
in the advanced cluster management team, they are coming up with strategies and have actually a capability right now to back up your ACM hub. The arbiter or the monitor service really it doesn't have anything right now to do with OpenShift. So it could be at the same location where you have your ACM hub on an OpenShift cluster, just because that location is determined to be highly available and won't go out.
It would
But
survive for some reason.
yeah,
Okay.
but right now your monitor service is not hosted inside for the Metro DR, because in that case, Ceph is completely outside of OpenShift.
Okay. I have more questions. Can I ask you a few more, or do you want to
Sure,
share some?
sure.
Okay. So when you do the pairing, right? Let's say everything's
Mhm.
regional DR. Let's just take Metro, one of them out of the picture, right? So no external Ceph. Let's say you have 10 clusters. When you pair them, you can only pair with each other. Like I couldn't say BOS1 pairs with BOS2, but BOS2 pairs with BOS3. Like I couldn't do something.
Yeah.
I'm just putting it out there.
Not
Like is
mhm.
there any wacky reason, or do they always like
Yeah,
once you
sort of
pair them,
like
that's it?
traversing through one or one to many or something like that.
Or if you had 3,
Yeah,
like making them go around so you don't have to do them in.
yeah. Currently, that is not supported,
Okay,
or the product is not configured that way. We are looking for that kind of solution. I can definitely see situations where you'd want one to many.
right.
Um, but right now it requires that you decide the two, and then you have to have configured them. And there's a configuration part of this. That's what I showed in the documentation. So
Right.
it's not just, you just create a data policy and say these two clusters you have to configure them to be in an asynchronous using something called Ceph mirroring, or you have to configure them to be synchronous by doing all of the configuration steps to connect to external Ceph. So what I showed in the data policies is essentially after you've done that configuration. So you're going to know, as a cluster admin, and you're going to know how you paired your clusters. But what I was attempting to show is that in the same view and the same advanced cluster management and the same data policies, you can have some clusters that are asynchronously doing disaster recovery and some that are doing disaster recovery synchronously.
So in this situation, so I have 4 clusters, let's say, and I have super important information like a hospital. I've got my Metro DR happening because I've configured external Ceph, and that's beautiful. If I wanted to, there's no way to configure, I mean, I'm getting really wacky, but I had an idea about like, okay, let's say I need to take a replication off of my Metro DR situation and put it off site and then have site, like, that's all. Like, you know how these things grow, right? You talk about
your question is
further away.
Your question is good. So I didn't talk about the idea of backup at all, but the traditional backup and recovery or restore, when you apply it to this solution, is totally complementary. Because if you think about it, whether it be synchronous replication or even asynchronous replication, you can replicate something that is corrupted. When you replicate something that's corrupted, there's nothing that can help you. So the reason we have backup and recovery is for that situation where either we have regulatory requirements to do backup or we're trying to protect and be able to go back to a known good copy of the data. So we do see, and you will see it in the future, where Red Hat solution right now that's now a certified operator, Red Hat certified operators, Openshift API for Data Protection, OADP. So you will definitely see OADP become complementary to the disaster recovery. So either on either side, either the preferred cluster or the failover cluster, I will want to back up and move that backup. And with OADP, it just introduced the data mover capability. So you can move your backup and your persistent data that you back up off-site. So if you need to, you can recover it. Okay. So yeah. I mean, it's not using like self-mirroring or the replication that we talk about.
Right.
But it's still very critical. Yeah, because you don't know when you're going to have corruption.
That's like corruption and total disaster, just to round out the whole disaster.
Yeah. Well, I mean,
think in terms of worst case.
And backup restore and even disaster recovery solutions, they've been around for all the legacy apps as well. So it's not like these are new ideas. We're just sort of containerizing and making it we hope easier.
Okay, so one more question. Have you been through a GitOps process with this? Is there any talk about what this would look like if you wanted to capture this in GitOps and Argo CD, or not yet?
I mean, the configuration part of it?
Yes.
Yeah. I personally haven't, but I know that our customers are thinking that way.
Okay.
And I guess from some point of view, our quality engineering group is doing it because they have to set up this thing, and they took the time to automate the setup, because the manual setup that's in the disaster recovery guide, there's a lot of it. I would say about 3/4 of it now is automated. So like when you create, say, the multi-cluster orchestrator and apply your first data policy, like 10 things happen behind the scenes that you don't have to do. Okay. 2 or 3 releases ago, the user who was trying to configure it had to do all those steps.
Right.
So the goal is to make the configuration as easy as possible, but you still have to, you still have to install stuff if you're doing Metro DR outside of OpenShift.
Of course.
Using the methods by which you install stuff. We can do more automation inside OpenShift with the regional DR. So there's still parts of it that could lend to what you're saying, but there, a lot of the things that were difficult before are now completely automated.
Okay. Fantastic. I remember those steps. There were a lot of them. So that's good. I'm glad. All right. We don't have any questions that I see, but so I think we can, and we're coming up on time. So that was fantastic. And
okay, and I didn't die, so that's good.
yes, that's always good. So this video is available. It's on one of our channels on YouTube. I can put it up in the description. And any slides that we want to make available, I'll make sure to modify the description of this on YouTube so everyone can take a look. And your video actually has a voiceover to it, so that they don't have to rewatch this. They can just go right to the video.
No, actually, yeah, it doesn't have all the commentary, but it's a shorter version. It's only 10 minutes.
Sorry, that was without me interrupting with questions.
The one I gave you is even more slick. It's only less than 9 minutes.
Oh, perfect. That's good. That's all my attention span can take anyway. So well, I want to thank you so much. I know it was really early for you, but this is really valuable, and it's really nice to see ODF at 4.11. Fantastic. Thank you.
Thank you, Michelle. All right, have a great day.
All right, everyone. Take care.
Bye.